Now, this embodies the fact that at the end of the day, behind AI sits a programmer who had an idea of how the world should work, coded this into the idea, and this is what we see in the algorithm.
Okay, so what is the definition of an activation function first? In an artificial neural network, the activation function of a neuron defines the output of that neuron given a set of inputs. So this makes sense given the illustration we had in the last video. We took the weighted sum of each connection that pointed to the same neuron in the following layer and passed that weighted sum to an activation function. The activation function then does some type of operation to transform the sum to a number between some lower limit and some upper limit. So what's up with this transformation? Why is it even needed? To explain that, let's first look at an activation function called sigmoid. Sigmoid takes in an input, and if the input is a very negative number, then sigmoid will transform the input to a number very close to 0. If the input is a very positive number, then sigmoid will transform the input into a number very close to 1. And if the input is close to 0, then sigmoid will transform the input into some number between 0 and 1. So for sigmoid, 0 is the lower limit and 1 is the upper limit. Okay, so now that we understand mathematically what one of these activation functions is doing, let's get back to our previous question of why we are doing this. What's the intuition behind it? Well, an activation function is biologically inspired by activity in our brains where different neurons fire or are activated by different stimuli. For example, if you smell something pleasant like freshly baked cookies, certain neurons in your brain will fire and become activated. If you smell something unpleasant, like spoiled milk, this will cause other neurons in your brain to fire. So within our brains, certain neurons are either firing or they're not. This can be represented by a 0 for not firing or a 1 for firing. With the sigmoid activation function in an artificial neural network, we saw that the neuron can be between 0 and 1. So the closer to 1, the more activated that neuron is. The closer to 0, the less activated it is. Now, it's not always the case that our activation function is going to do a transformation on an input to be between 0 and 1. In fact, one of the most widely used activation functions today, called ReLU, doesn't do this. ReLU, which is short for rectified linear unit, transforms the input to the maximum of either 0 or the input itself. So if the input is less than or equal to 0, then ReLU will transform the input to be 0. If the number is greater than 0, ReLU will then just output the given input. The idea here is the more positive the neuron, the more activated it is. Now, we've only talked about two activation functions here, sigmoid and ReLU, but there are many different types of activation functions that do different types of transformations to their inputs.
One of the things I really fear about these tools is that they are ways of automating austerity, right? So all of the designers that I spoke to said, you know, these tools are regrettable but necessary. They're tools for doing triage because we have all of this need and not enough resources, and we have to make these hard choices. And back to your point, we actually don't want to make those hard choices, so we're going to let a computer make them. So they're kind of empathy overrides. And I was sitting in one of those labs in 2000 with a young mom on welfare who goes by a pseudonym in the book. She goes by the name Dorothy Allen in the book. And we were just kind of shooting the breeze about technology. And I asked her about her electronic benefits transfer card. These EBT cards are these sort of debit-like cards that you get public assistance benefits on. And they've been around for a long time, 25 years or so. And she said, oh, you know, it's more convenient in some ways than actually like carrying paper food stamps. I think there's maybe probably some less stigma in the grocery store, but everybody still knows when you're using an EBT card. But, you know, maybe there's a little less stigma than pulling out food stamps. She said, oh, you know, but my caseworker also uses it to track all of my purchases and all of my movements. So she would go into a meeting with her caseworker, and her caseworker would say things like, you know, why are you doing grocery shopping at the corner store? Why aren't you going to the grocery store? You'd save money if you went to the grocery store. And, you know, of course, there are reasons that you shop where you shop that weren't necessarily clear to the caseworker. But I must have looked super, super shocked when she said that to me because she kind of pointed and laughed at me for a while. And then she got like kind of quiet and more serious, and she's like, oh, Virginia, you know, you all, meaning like professional middle class people, you all should pay attention to what happens to us because they're coming for you next.
And I think what unfortunately happens with the discourse around predictive systems and machine learning is there's an assumption that these technologies are neutral, whereas the reality tends to be that they just imbue the culture that they're made in. I think the framing of the question as solving bias is actually inaccurate. It's like, what bias are we putting in?
And I think if we're concerned about transparency, then maybe we should think about why we're so concerned. Are we concerned about transparency because perhaps we are a bit ashamed with what our machine learning is doing? Or perhaps what we're doing we would classify as unethical or immoral as people? Finally, models can learn unintended stereotypes or biases from our world. I mean, depending on where your data is coming from and who's labeled it and how many mechanical Turks were used and how much instruction they were given before they were mechanical Turking your data, this could be a problem for you.
We are starting to see more and more real-life, everyday applications which are around us and which we start to use all the time. And one of them, for example, is that we have now machines that we can talk to on our phones, or we can ask them questions at home, and are always listening to us, ready to answer these questions,